afternoon, young scientists. The objective of today's experiment is to work out the density of different materials. Density is a measure of the mass of a material per unit volume. So to calculate density, we need to measure the mass and the volume of some different objects. What we have here is a piece of cork, a piece of wood, a piece of polystyrene, a piece of pumice, a glass marble, a river pebble, a rubber bung, and a lead sinker. We'll take one of these as an example, the lead, and you will probably already understand this as something that sinks in water. To get the mass of the lead, we need to make sure that our balance is on 0 and we have the measurements aligned with 0 on this side, or at least very close to 0. We put the lead weight and we note that it pushes it down. We need these balances, which we use the hundreds, the tens, and the ones to try and balance it out. The first thing we'll do is move the tens and see whether it starts to balance out the lead weight. We get up to 100 and we notice it isn't balanced out, so we move it back and move the hundreds up to 100 and then start adding more tens. We notice that the 110 pushes it down, which means that the lead is less than 110. So we push this back to 0 and we start measuring, pushing the 1 up. We still don't have it balancing down to 0. 0 indicates that it's balanced. We just keep adding a little bit more, and we get to about a value of 100, no tens, 8 units, so it's 108 units, 0.0. Once we have a mass, we have something we can write down in our results. For mass, we now need to work out the volume. We work out volume by displacement of water using a measuring cylinder. We can have a look. We have filled up the measuring cylinder to 50 milliliters. If we put the lead ball into the water will rise, and the change in the volume will be the volume of the lead, because that is the amount of water that the lead has displaced. However, if we drop the lead into the measuring cylinder, we're going to have water splashing out. So we solve that problem by putting the lead sinker into an empty cylinder and then pouring the water in. If we pour the water in, the lead is not going to splash out, nor is the water. So we had 50 milliliters. We have water plus lead, and it measures 55 milliliters. We can then calculate the displacement of the water by the lead as 5 milliliters. It is 55 minus the 50 for the water that we originally had. So, right, we are ready to calculate density. We have a measurement for mass, we have a measurement for volume for our what we call lead sinker. If you remember, it was 108 grams for mass, and we calculated 5 milliliters that this lead ball took up, the volume. You do the maths and you come up with a value of 21.6. The units is gram per milliliter. So in this case, the lead sinker, feels like lead, it does look like lead, has a value of 21.6 grams per milliliter, a value you could go and check up on the internet and see how it compares to lead. If it's more, then it is something that is more dense than actual lead. If it is less, then it is probably something that is much less dense than lead. We'll leave that for you to check.